Okay, so we're starting a new chapter today, chapter 6, and we'll be doing exercise 6a, interpreting straight line graphs. So let's get started. The graph shown here shows the journey of a cyclist from one place to another. Now, the idea of graphs in general, especially of this type of graph, is that it tells you the relationship between two things. So over here, it's telling you the relationship between the distance traveled and the time taken. So in 1 hour, how much distance was traveled? So if you know one of these two things, you can figure out the other one because you have a relationship. This line shows you the relationship that links time with distance. And so if you travel 1 hour, how much distance have you traveled? We can draw a straight line up, more or less like this, and then you draw a line vertically and you can say, oh, hey, in 1 hour, the distance traveled was 10 kilometers. And that's what a straight line graph allows you to do. And that's what a graph does in general. It links two variables. In this case, it's linking time with distance. Anyway, let's get started with the question. How far did the cyclist travel? Well, cyclist took 2 hours. How far did he travel? 20 kilometers. Because at the end, he started at A, went to B. At the end, he was 20 kilometers. So 20 kilometers is how much the cyclist traveled. How long did it take the cyclist to complete the journey? 2 hours. How long did it take? Time. How long time? 2 hours. Notice that it is in hours, and that's how I know it's not 2 minutes and it's not 2 days. It is in hours. Time has been given in hours. If the cyclist rode from A to B and then halfway back to A, how far was the journey? How far was the journey? Tells me I'm talking about distance. Now, one way is 20 kilometers, and then if I went halfway back, it's another 10. So 20 plus 10 gives me 30 kilometers. And I will move forward. As always, if you have any questions about the worked examples or just from the homework, you should ask me on Slack. Moving on to the next question. Number of rabbits in a colony has decreased according to this graph. How many rabbits were there in the colony to begin with? Well, to begin with means time is 0. At the start, how many rabbits were there at the start? And at the start, there were clearly 80 rabbits. Number of rabbits is 80. And so we'll write 80 here. How many rabbits were there after 9 months? Well, we'll look at the graph. Time is over here, 9 months, 9 months. How many were there? And they've drawn a line here for us. And 20, 30, 40. That's 30. So how many rabbits were there in 9 months? 30 rabbits. 30. I hope I can fit this. 30 rabbits, 80 rabbits. Make it a habit to include, the unit, so to speak, quote unquote. Over here, we're talking about rabbits. All right, 30 rabbits. How many rabbits disappeared from the colony during the 9-month period? Well, if you started with 80 and you ended up with 30, 50 disappeared. 50 rabbits disappeared. And here's a quick tip for you. Disappeared. A quick tip. Anytime you're doing a word question, you should try your best to give your answer in words as well, as a sentence. I know it sounds like a little bit of extra work. It might be, but it'll stop you from making silly mistakes because writing a sentence forces you to think about what you're writing. Because you have to think about, what does 50 mean? And then often when you think about it, it'll stop you from making a silly mistake. So yeah, that's a very, very handy tip. I hope you take it on board. It's very, very useful. Moving on. This graph shows the growth of a tree over 5 years. And that shows a ratio between time, years, and the height of the tree. All right, cool. Over 5 years, I can say it's 5 years, became 15 meters. All right, let's look at the questions. How many meters has the tree grown over the 5 years? Well, it started off, it seems like it had a height of 0, so maybe it just got planted. But in 5 years, it was 15 meters tall. 15 meters. How many meters has a tree grown over the 5 years? 15 meters. Use the graph to find how tall the tree is after 2 years. And so this is what you do. And you find 2 years, you draw it up, and then you draw like this red line shows us. And now we're going to have to estimate roughly how tall the tree is after 2 years. Maybe 6, because what? 6, 7, 8, 9, roughly 6. Yeah, I'm satisfied. 6 years. Find how tall the tree is after 2 years, 6 meters. Use the graph to find how long it took the tree, how long it took for the tree to grow to 10 meters. Well, 10 meters, you find 10 meters and you draw this line as it shows you, and you go down. And look, that would be around 3.5. That would be a quarter, so it's a bit more. So maybe, I don't know, 3.3 years, 3.4 years, something along. I reckon 3.3 years, roughly. And when you have something like this, a rough approximation is perfectly fine. There's absolutely nothing wrong with giving a rough approximation. Okay, moving on. We are going to do the next question. Due to poor performance, the value of a company's share price is falling. All right. By the end of August, how much has the share price fallen? By the end of August, how much has it fallen? Well, how much has it fallen? Roughly around $1. It started off at $2, so it fell by. So this is where it's helpful to write your answer as a sentence, because a lot of students will write, they'll just read this value and they'll say, oh, that's the answer. But it's asking how much has it fallen? So how much did it start off? And then how much did it fall? So that what we're after is here. That's the amount we're after. How much did it fall? It went from there, it dropped down, and the new value is there. So often helps to read the question carefully and try and give your answer in a sentence if possible, or at least in words. So how much did it fall? It fell by $1. And when you write your answer, make sure it's answering the question. You read the question, make sure you answer the question in words. It fell by $1. Okay, at the end of November, okay, November's over here. What would you estimate the share price to be? Okay, now something that this is a concept that you need to understand. There are two things you can do here: interpolation versus extrapolation. These are fancy words. All it means is interpolation means inside the data. Extrapolation is extra on top of what the data you already have. Now, interpolation would be if you're trying to use this line, to give answers within the line. Okay, so anything along those, anything over there, this is the data you have already. And the red dotted lines, these are guesses. You look at the pattern and you guess. Now, you have to be very careful with extrapolation. We have to be very careful with guessing, because sometimes or often you can't use extrapolation reliably. For example, let's say I drew a curve. Let's say I drew a graph of, your height. Let's say I graphed the height of a typical teenager. Okay, so teenager starts 11, 12, 13 years of age. You start off at 13 years of age, and you have 14, 15, 16, 17, 18, let's say 19. Okay, and let's say you start off at, I have no idea, 13 years old, you're 1.4 meters, let's say. And then, at 14 years of age, 15, 16, 17, and I don't know, 18, ignore that. So let's say you grow like this. 18. After 18 years of age, you're at your max height. Now, my question to you is, can you extrapolate? Can you predict, using the information you have, can you predict their height at 30 years? And then would the height keep growing like that? Would the height keep growing like that? And the answer is no, because after 18 years of age, you stop growing. It'll be like this. It'll be a flat curve because people don't keep growing for the rest of their life. If anything, once you reach a certain age, you start growing shorter when you reach old age, perhaps. And so, yes, you can use the information you're given in the data set. Interpolation is fine, but when you extrapolate, you have to be careful because you won't always be able to reliably use the data you have to guess and predict in the future. I hope that makes sense. So let's get back to the question that we were doing. Just gonna write this off. So the question is saying, at the end of November, what would you estimate the share price to be at the end of November? If that trend keeps going, if that pattern keeps going, it's going to have a value of $0. In other words, this business will be bankrupt. It won't be worth anything. It'll be $0 the share. Near the end of which month would you estimate the share price to be 70 cents? 70 cents, roughly around there. They've drawn this red line, and clearly we can see September.
Also,
yes.
So what is a share price?
Go on, ask. Feel free to ask.
Yeah, what is a share price?
Share price. Okay, so a share price. If you have a business, right, and there's something called a public business, a public enterprise. This is basically when a business needs money. They can sell a part of their business to the public. They'll say, does anyone want to buy a share of the business? And for example, you can buy a share in Coles. You could buy a share in Myers. You can buy a share in Telstra. And the advantage of buying a share in Telstra and so on would be that when Telstra makes a profit, let's say you own 1% of Telstra. If Telstra makes a profit, then 1% of the profit will be given to you because you have a 1% share in Telstra. And that's what the share is basically. So the share price is falling means that the value of one share in the company is going down. And basically the whole company is getting valued less and less because the share price is falling. Hope that answers your question. You will do more work on this, maybe in commerce, but definitely in business studies. Okay, look, that is all the worked examples I'm going to do today. If you have any questions, you can ask now, or I'm going to stop recording. You can ask me then. I'm stopping the recording. Stop.